Hello, I am Eyüp Mahmutoruz from Moldex3d EMEA team, and today I'm going to present optimized plastic part designs with Moldex3d Sync. First of all, I'm going to introduce manufacturing process. Then I'm going to talk about Moldex3d Sync, what it is, and we are going to talk about CAD design verification, supported versions, and at the final, I'm going to show a demo and case study. Let's start with the challenges. Nowadays, product and mold become more and more complicated. With more complicated products, we're still willing to have low prices and decreasing period, which means we are trying to decrease the cycle time to get more products in one day. Also, companies try to keep market competition with the best product quality. So if your product is not the best design, you will spend a lot of unnecessary costs during the modeling process, such as increase the time to launch the market, a lot of tooling costs, material loss, and low product quality. And the final, we can say you're gonna waste time and waste cost. So why we need CAE analysis for injection molding? We can say three different phenomena in this area, like complicated physical phenomena. So you don't know what's going on in the mold, the complicated material property, and complicated geometric feature. Also, for the best quality part, we say we need to care about four different things like part design, mold design, process selection, and material selection. So in Moldex3d, you can choose several materials to do analysis. Also, from the results, you can see if your part design is good enough to produce the mold. Also, you can choose proper proper process selection. Okay, what is CAD, K, and CAM? First of all, first two letters C and A stand for computer aided, so we use computer to do design or to do engineering or manufacture the part. If we talk about different positioning between CAD, CAE, and CAM, we can say these three different softwares play different role in a different development stages. For the CAD, we can say we care about the design, so we do the geometric design, component definition, and material design. For the CAE, we do the simulation what we designed before. So we simulate the material, we simulate the engineering. For the CAM part, we do the 3D prototype production and product process design. So this is the typical product life cycle. We start with design needs. We define the design needs, then specifications. We collect the relevant design information and feasibility study. We conceptualize design and we model the design and simulate it. This is all CAD process. After CAD process, we start the CAE process with the analyze the design. After analyze the design, if we have any problem with the design, we optimize it. Then we evaluate the design and design documentation and communication. We give this part to the CAM part, which is process planning. So as we see from here, design analysis to design documentation and communication, this is the CAE part, what we do in Moldex3d. Then we go to the CAM part. We plan to process, we plan to production process, we design and procurement of new tools, we order the materials, and then NC, CNC, or DNC programming. Then we product it. After checking the quality, if the quality is okay, we package it and ship it to the market. Let's talk about features and benefits. First of all, what is Moldex3d Sync? Moldex3d Sync allows you to use Moldex3d or CAE analysis without leaving CAD software. So you are gonna do the analysis, CAE analysis in CAD environment. From here, as we see, part and mold design, which belongs to CAD software, and CAE verification, we do integration between CAD and CAE process. Then this is for CAE CAM part and the production. It's also very easy to use Moldex3d Sync. It's easy and automatic meshing. So we have CAD integration, and it's also very quick and good accuracy. From here, we can see Moldex3d Sync features. First of all, we fully integrate with leading CAD softwares such as Creo, NX, and SolidWorks. The workflow is very easy. After you design your part, you launch the Moldex3d Sync and you continue to analyze your part. So you have direct access from familiar CAD interface to Moldex3d simulation. You don't need to leave your CAD interface. Without intelligent and robust technology, so the mesh is fully automatically created 3D mesh. So you just choose the mesh level like 1 to 5, and it's gonna create it automatically. After you analyze finished, if you wanna get the report, your report is also automatically created. So if you are using your laptop and you don't wanna run the simulation in your laptop, you also can use parallel computing technology to connect another computer to run analysis. So in Moldex3d Sync, we also support full Moldex3d analysis like flow, pack, cool, warp. Let's talk about Moldex3d Sync benefits. We fully embedded in leading CAD softwares, Creo, NX, and SolidWorks. The workflow is very simple and it's also very efficient. Like it takes 3 or 4 minutes to get your part is ready to analyze. You don't need to convert any file to the analyze because you are using your CAD software and you are gonna do the analysis in your CAD software too. So you don't need to worry about data loss and tolerance problems. You don't need to revise your model before the analysis. It's very easy to learn. I'll show you a demo about this one. Let's talk about the workflow. First of all, if you look at this part, Moldex3d Designer and Project, Moldex3d Designer is what we use for the pre-process, and Moldex3d Project is what we use for post-process. In Moldex3d Sync, we do whole things together. So if you design your part, after you design your part, you just launch Moldex3d Sync and do the analysis of your part, like flow analysis, pack analysis, cool analysis, or full analysis like flow, pack, cool, warp all together. So as we see from here, you model the part, you do the analysis. If result is fine, you do the mold design tooling. If result is not fine, you change your design and analyze again. Then when the result is fine, so you do the tooling time. This is analysis capacity of Sync. For the part design, we can optimize part designs, like what we designed before. If there's any problem, we can design it, and design verification and PLM integration. But if we look at for Moldex3d Sync, what we can analyze. If we start from tooling validation, we can see how many tons that we need for clamping force, or if the runner is balanced or not. For the product lifecycle efficiency, we will see the cooling time reduction with using Moldex3d Sync. We all know cooling time takes 70% of the cycle time. So cooling time reduction is very important for us. For the quality, we can see warpage prediction. So we can predict shrinkage too, and if the flow is balanced or not. For sophisticated process, we can say fiber orientation, mold gate control, advanced hot runner, and conformal cooling. That's all fine for this Moldex3d Sync. Like multi-component molding, if you have a part insert, in the analyzed result, you can see how your part insert is affected by the flow. And it's also very accurate. This is quick verification of analysis result. We model the part and we simulate it. So this is CAD part, this is CAE part. In Moldex3d Sync, we all do this in a CAD software, CAD environment. So we find the potential problems here. Okay, this is a filling problem. Then we need to change the design for high risk area. After change design, we analyze it and we see we have better results. Then we can continue to mold design and manufacturing process. Let's talk about what we can do in Moldex3d Sync in some samples. In Moldex3d Sync, we support up to 4 gate location prediction. Like you don't know where to put the gates or how many gates you want to put. So you can try Gate Location Advisor and it tells you where to put gates. If you are gonna use one gate, it's better to put the gate here. If you wanna use 2 gates, maybe it's better to put 2 gates here. It's up to you. So we support up to 4 gate locations prediction. For the estimated cooling time from the results, we can see which areas need more cooling time. So if our cooling time is not enough, it also affects warpage. So we are gonna arrange the cooling time better, or we can adjust the cooling time longer, so we get better cooling effect. For the sink mark and flow length ratio, we can also say about the flow rate distribution here, as we see how the flow goes and flow length ratio. For the sink marks usually happens at rib areas, as we see, or corners. So Moldex3d Sync shows potential sink mark areas to eliminate the problems which is caused by the sink mark, like burn marks or etc. Okay, for the filling analysis, we can predict the potential air trap areas. So maybe we need to put some venting here to eliminate these problems. Or weld line, we can predict the weld line, like where it's gonna be there. Or we also do another weld line results, like weld line meeting angle and weld line meeting temperature, which also affect the weld line. And for the clipping, inside the part, maybe we are gonna look for temperature, so we can use clipping function to see inside the part. So in Moldex3d Sync, we support full analysis, complete analysis like flow, pack, cool, warp. And we also support fiber orientation and insert molding. For the supported versions, we have for the Creo, NX, and SolidWorks, Moldex3d, R17 all support these CAD softwares. So for the supported versions, we can say Creo 2.0, 3.0, 4.0, and 5.0. For the NX, we have supported versions like NX 8.5, 9, 10, 11, 12, and SolidWorks 2014 to 2019. I have two demo and case study here. I'm gonna start with the demo. Demo is so this is SolidWorks interface. Then I'm gonna insert my components. I already applied two components here. This is my part, and I'm gonna click to put it 0, 0, 0 point. Then I'm gonna choose runner and my cooling system together. After I imported these parts, I'm gonna save it like the assembly part. This is a necessary part for SolidWorks scene. Then I'm gonna launch Moldex3d sync. I use my computer to demonstrate the demo, so it takes some time. So then I'm gonna choose the components. I have two different parts for the Moldex3d analysis. Then I'm gonna create a part file. So as we see, this is SolidWorks interface, and I'm gonna use the Moldex3d in SolidWorks interface. As we see, part, runner, all the system. Then I'm gonna click the part, choose my part here, and I'm gonna select the material. In Moldex3d material database, we have more than 8,000 materials. So you can choose the material which you wanna choose. So I'm gonna choose one of them and click yes. For the runner, my runner is already designed. Then I choose the runner, and I'm gonna use the hot runner. It also supports hot runner or cold runner. Both are fine. Both is fine. In here, I choose the melt entries. The melt entries tells the software where plastic starts to flow from. Then I create the mold base. Mold base is created automatically, but I know the distance between the cooling channels. So in cooling channels, for the cooling channels, cooling entrance and cooling exits should be on the mold base. So I know the diameter 400 millimeters, so I choose the 400 millimeter. And I choose the mold base material, like which metal I'm gonna use for the mold base. So mold base is created automatically. Then I'm gonna choose my cooling system, cooling channels. These are my cooling channels. And I'm gonna put the coolant entrance, coolant inlets and outlets. So you need to choose a coolant entrance, which is inlet and outlet by yourself. So I'm gonna define it quickly. And last, I'm gonna choose a coolant exit, which is outlet. And that's all part for the pre-process. Okay, then I'm gonna start to run analysis. Okay, I'm going to use eDesign mesh. As we see from here, I can choose a mesh level, like 1 to 5. I can choose normal mesh, or I can choose coarse, coarsest, or fine, finest. Then I'm going to choose the analysis sequence, like I'm going to do the full analysis, cooling, filling, packing, cooling, and warpage. Then I'm going to set the process condition. This is filling time and packing time. Also, we can see what it is in here. This is cooling time. I'm going to set it 10. Also, we have advanced setting here, which is we click advanced setting. We connect the Moldex3d process wizard here. Also, you can adjust the process with here, with using this one. So if everything is okay, I'm gonna start run immediately. Then I'm gonna click yes. That's whole process for your CAD part to get ready for the Moldex3d analysis. It takes some time. So at the final, I can see my analysis start to run. Okay, we also have one more case study here. For the case study, we are going to use eDesign Sync for SolidWorks. So we need to design optimization by using Sync on a simple connector model. First, I open the connector model. Then I launch the Moldex3d Sync here. Then I choose my part, click part, and choose a solid geometry as part. Then I choose the material. For this part, I'm going to use the LCP material. Yes. For the runner, I'm going to choose a solid model as runner. So it's going to be called runner. Then I'm going to define the melt entrance, which is telling us where the plastic starts to flow from. Okay, this is the plastic starts flow. The melt base, it's going to create it automatically. I don't need to adjust something, and mold base material is automatically chosen. If you want to change it, it's okay to change it. Before analysis start, we have to set the simulation sequence, process conditions, mesh level, and click the run analysis. So in here, we are going to examine the results. In filling analysis result, we check the flow pattern from the melt front time results. So it shows the obvious racetrack effect in filling animation. So the racetrack effect leads to unbalanced filling and may cause uneven volumetric shrinkage, air trap, weld line in the part. So if we look close here, if we watch the animation again, we can see the air trap. Okay, sorry about that. Click wrong. Okay. If we watch the animation again, we can see the air trap and weld line indeed exists in this flow simulation. So we are gonna make some changes on the model. The racetrack effect can be solved in several different ways. For this part, we will decrease the thickness on one side of the part to balance the flow. So we use several CAD tools in SolidWorks to cut a slot on this side of wall, as we see. It's here. So we want to analyze the modified model to confirm the design change is effective. For comparison, analysis setup is the same one as the original one. So we are going to examine the result of the revised model. We find out that the flow pattern of melt front is more balanced than the original one, as you see. The melt front evenly reached the end of the cavity almost the same time. Okay, in here we can say because of the balanced flow behavior, the revised model shrinkage is more even than the original one. So it also affects our warpage. We get better warpage results. So in here we did the 4 things. We perform an injection molding analysis for original connector model. We examine the analysis for the original connector model. We see the problem here. Then we modified it. After we modified the model, we do the analysis again. And we see the result is fine. Then we check it. Then we can start to do mold tooling. And it was the end of the presentation.